Good morning. In this class, we're discussing about the case study about structural analysis of bridge. As we know that, okay, there are n number of analysis will be there in finite element analysis. That is, one of the topic is structural analysis. An example, other analysis we call as the dynamic analysis or heat transfer analysis, and also CFC, that is called as fluid dynamic analysis. So now we can discuss the basic concept about the structural analysis. We're discussing about the structural analysis of bridge.
Um, Myself Harikrishna. Today we are going to see about the topic of structural analysis of bridges. Bridges are the most critical and most varying forces in finite element analysis because bridges have the static forces and also a dynamic forces. Static force is nothing but a bridge load, and the dynamic force is adding weights or like cars, bikes, and trucks, etc. And this analysis cannot be done physically by constructing a bridge, and after that we test with loads and weights. Before constructing it physically, we do some analysis in digital mannerism like digital twin technologies. By using this digital twin, we can easily analyze the structural components of the bridges using finite element analysis. By taking the small finite element of a complete bridge, we can easily find the composite materials and load carrying on a finite part of the complete bridge. So by this we can easily observe all the failure factors and the positive factors of the bridge in digital mannerism itself. So this help the bridges construction to be fast and also safety. Main use of finite element analysis in this bridge construction is safety concerns.
So now we'll see the problems in this bridges infrastructure, building infrastructure. So bridges are, as we said, is one of the most crucial logistical thing we need. So the main problem with bridges are if a bridge is to connect a land and a land, in between there is a river, so there won't be any supporting structure in between those. So the pressure in it will tend to develop in the middle part. So the bridge tend to break when vehicles are traveling through the middle region of the bridge. So what they will do is they will try different methods, which is one tensile or other is hydraulic methods, where the bridge is partially supported and hydraulics are used to open and close the bridge. And this problem will not be seen in bridges where there is a land in between. So that they will place pillars in between so that the weight is distributed over along all equally all over the bridge. There is another problem in which the metals used in the bridge tend to expand and contract during the change of the season in the years. In summer it tends to extend and in winter it tends to contract, so which will cause damage to the bridge over a period of time. So what we'll do is we'll virtually simulate the whole bridge structure in a computer, and we'll use ANSYS or software simulating software which is FEA to mesh and to apply boundary condition and process the result.
So next we can see FE implementation in structural beam. First, the bridge beam is modeled or designed by using the computer software. Then it was divided into each element for a meshing process. Then engineer can give stresses and load of the vehicles, and then environment supports. After that, uh, we have received the result of the by using the software, by using color codes. Uh, then we have see the maximum stresses by using color code.
So, as for the result and solution, for the result, after applying the load conditions and the boundary conditions, we resulted in a stresses that act on the beam joints, which can be rectified by adding more pillars on the center and optimizing the length and the width of the road. So, after finding these problems in FEA, we redesign the model and we recalibrate and we resimulate the model and we get a better result. So this proves that FEA helps engineers to optimize models and paths before entering prototyping, and it reduces cost and improves efficiency through analysis.
As in this video, you know that the case study about the structural analysis of bridge, you know, understand the basic concept, how the answers will be working, and what are the scenario we are using the bridge for calculations for while doing manually and answers solve the problem. Okay, yes, thank you.
Right.